Alrighty. Hi, everybody. Thanks and welcome to the first Art and Art History lecture series of the semester. We have several great talks planned for this term, for each month, actually, and two in November. So we hope you'll join us for each of them. I'm Kate Parsons. I'm a professor over in studio art, in digital art, and we're just really excited to have this talk for you today and to partner with the library to make it happen. We also want to thank Sustainability for partnering with us on this. This is our first and only talk that focuses on art and sustainability for the semester. I wanted to introduce you to Emma Akmakdjian. She's an interdisciplinary artist who translates climate data and system processes into interactive installations to dissolve barriers between nature and culture and contextualize the ocean climate crisis as a sociological dilemma. She collaborates with scientists on projects that include workshops, interviews, and experiments that demonstrate how subjective experience inspires people to interpret the material world differently. Her work focuses on marine ecology, taking inspiration from her experience as an AAUS scientific scuba diver. She received her MFA in the Design Media Arts program at UCLA with a certificate in Leaders of Sustainability. She's a friend, an incredible artist, and an adjunct professor here at Pepperdine in the studio art department. Join me in welcoming Emma.
Give me a second to turn that on. Oh, good, it's working. Hi, everyone. Welcome. Thank you for being here. Thank you so much, Kate, for that introduction. Oh, yeah, we got two going on. Maybe that's a little overwhelming. All right, sweet. Yeah, as was mentioned, I am a professor here in the art department, the Seaver College in the art department. I teach introductory art, and when I'm not working here, I'm working on the Channel Islands. So I also do ecology and environmental restoration. And that really fuels my art practice and my teaching in the classroom. Here's an assemblage of the things I'm doing when I'm not in class. I'm picking up a lot of trash on several different beaches on the island and studying what's washing ashore and what we can do to minimize waste. When I'm not on land, I'm underwater. So that's me holding up an abalone shell that I found in Palos Verdes. So I've been studying and helping out with restoration projects. And I like to spend my time volunteering when I'm not working and giving back to the environment. In addition to working at Pepperdine, I'm the marine debris coordinator for California State University Channel Islands. That's a part-time appointment, and we go out to the island 2 times each season, and we go to 2 different islands, Santa Rosa Island and Santa Cruz Island. And we bring together a group of volunteers that are CI students and other people and organizations that are cleaning up waste up and down the Northwest Pacific. I also am an intern. I intern or help interns at West LA College. Right now, they're working with Kelp Arc in Alta Sea. And so they're doing a feasibility report and studying kelp restoration for the next 100 years. So they're using Landsat data. They're projecting into the future how the trends for kelp forests and coastal ecosystems is going to change with different socioeconomic situations. So if we continue drilling oil, or if we decide to go more with the green agreement and be a little bit more conservative about how we're using resources. So I'm really interested in that intersection of ecology, art, science, and the economy, because they're all very related. And then I did my American Academy of Underwater Sciences, my scientific diving certification with UCLA. And then in addition to that, if you like to listen to talks about the ocean and ecology, I host a speaker series called Kelp Culture, and we host monthly talks from people from all different backgrounds and perspectives, all cultures, talking about the ocean and what it means to them. So we can get more of a holistic and inclusive representation in the sciences and in the arts. To talk about my art, we have to travel over to the Northern Channel Islands. Has anyone been to the Channel Islands? Yeah, a couple of people. Awesome. Do you know what islands have you guys been to? No worries. Awesome. Yeah, so those two are part of the Northern Channel Islands. So Anacapa is that really tiny sliver of an island. Anyapak is the Chumash name for Anacapa. Next over that is Santa Cruz Island going west, and that's the largest island in the Northern Channel Islands. There's actually additional islands, so I think the most popular and the one that people visit the most frequently is Santa Catalina. Has anyone been to Catalina Island? Okay, a few more people. Yeah, Catalina. Yeah, now you remember. It was Catalina Island. Awesome. Sweet. And the islands that I primarily work on are the largest ones. That would be Santa Rosa, the one that's kind of heart-shaped, and then also Santa Cruz Island. And those are like, some of those beaches are like catcher's mitt, and we get lots and lots of trash that wash ashore there. How did I get involved with this? I studied art. I did my Bachelor of Arts at California State University, Channel Islands, and I also did my master's in design and media arts. I got involved with it because I found out that my university in undergrad had a research station on Santa Rosa Island, and they were trying to promote students to be more involved with nature and more involved with sustainability. Going out to the islands was amazing because this is going to scare a few of you, but there's no internet connection, there's no cell service, and you're in a bunkhouse with like 20 other students, and it's very remote. So there's no concessions, there's no grocery store, there's nothing but you, nature, and the group that you brought out there. And so you rely on other people to cook you dinner, to cook with other people, and it's a very holistic community setting, which doesn't happen very often. And I found it really rewarding to be out there and connect with people in a way that you don't connect with when you're on your phones and on the mainland. So I started going out like weekend after weekend. I was like, yeah, like let me volunteer, let me help out. And one of the projects they were doing was this marine debris project where they're going to the beaches that nobody has seen all year besides the pinnipeds and the sea lions and the dolphins. And we would just pick up everything that was washing ashore and studying it. And so this is one of the maps from that project. And this is specifically derelict fishing gear, which is fishing gear that's gotten lost from the commercial industry that's fishing up and down the coast of California. I sat on many meetings with the fishermen, and we're trying to kind of come up with ideas of how to reduce waste and continue to let fishing be part of the economic system. So what does that look like? The types of fishing gear that wash ashore are very various. Most of them are plastic. So after the 1950s, everything transitioned from glass and hemp and silk to nylon, polyethylene, just plastic, plastic, plastic. So I was sitting in front of Gretchen and her art student, and they're talking about sustainability, and even just the concept of acrylic paint, it's all plastic. And so like oil paints being in the past. And so I'm always contending with this in my art process. What was art making in the past? What is art making now? And what can art making be in the future? And how can the process of making art be a part of sustainability? So that's part of the project. The other thing that I started to get familiar with being out there is that the beaches are really remote. So even though trash is washing ashore, it's not the typical kind of waste. And some of the beaches are really clean. And you know, you might go to the beach and you might say like, oh wow, you know, the beach is really clean. Like even Surfrider Beach down here, sometimes it's really clean and it has everything to do with the currents. Like I promise you, all that trash is out there, it's in the ocean. But when we're walking on the beach, we'll find things from every country. Like it's not just trash that's local. So even though commercial fishing is a large part of the trash, we find everything. And the other thing are these kelp forests, right? So I'm looking at the waste that's washing ashore, and I'm looking out at sea and thinking about all the waste that we're not seeing, but that's out there in the ocean. And so trying to think of these two data sets and let that inform my art. So this was one of my pieces I did when I was an undergrad. This is meant to look like a type of kelp that grows in the kelp forests on the Channel Islands. And I was using the data on the right to incorporate that into the weaving. So the proportions of the weaving and the color coding all reflect the data. So black being the most predominant would be plastic as a material, and so forth and so on. And I wanted to create this forest that was completely made out of waste that was collected on the island to represent the stuff that's out there that we're not seeing, and also thinking about the disappearance of kelp forests. Has anyone dove in the kelp forest or been around the kelp forests or gotten annoyed at them when you're stepping on the beach and you find a bunch of slimy seaweed? Maybe. Yes. Oh, amazing. Yeah. So In Southern California, the Southern California Bight is everything from Point Conception in Santa Barbara down south to Baja. And the kelp that we get there is called giant kelp, and it's absolutely beautiful. Being in the kelp forest is like being in a cathedral where like the whole canopy of the kelp is this golden yellow, and there's these like pin needles of light shining through, and it's all yellow, and it's incredible. And there's fish that rely on it, all types of marine mammals. It's also the home for the spiny lobster, which has anyone here like eating lobster? Maybe, yeah. So lobster is a very, it's a food. It's a source of our life, and it's something that people have been eating for thousands of years. And I kept continuing on with this project for a few years. So this was in 2019. This was a variation of it, playing around with all the materials that we were finding on the beach. And then I overlaid that with video and interviews from fishers and scientists, all talking about their practice and how they would imagine it being more sustainable in the future. But as you know, if anyone has taken a class on environmental science, there's a lot of reflection on the past. How have things changed, and can we get back to the way things were? And is that even the end goal? Do we really want to go back in time and make it exactly the way it was? Because is that even possible considering how much has changed? Can we just like get rid of the invention of plastic? I'm not so optimistic that that's what we can do, but we have other things that we can work within our means. So maybe not idealizing the past, but moving forward and trying to think of how we can contend with the changes and do what we can. And so there's a lot of reasons why kelp forests are disappearing. Plastic is not the reason they're disappearing, but overfishing is one of the reasons that they have been disappearing. Heat in the ocean has been increasing over the last 100 years. And so areas that were historically very good habitat for kelp forests are now becoming very sparse, and they're getting pulled up with massive storms, increased storms, heat blobs that are coming up from the Northwest Pacific and just killing thousands, like millions of sea creatures in one go. And then disease. So when you get an increase of temperature in the ocean, you also get a lot more bacteria and viruses that prefer the temperature. So think of your blood, for example. If you have a virus in your blood, the temperature is perfect. It can continue to like replicate itself, or a bacteria to continue to replicate itself, and it can take over. And so the same thing happens in the ocean. The ocean, like ocean water, is like the blood in your body. Like if the ocean water gets hotter, it creates a perfect habitat for more bacteria to be in the ocean water. And so one of the really important species that was keeping balance in that ecosystem started to completely disappear and melt away, and that was the sunflower star. So thinking of this concept of traveling back in time, thinking about the fact that the ocean is warming. While I was in grad school, I started reaching out to scientists who were studying this exactly, who were trying to look at how the biology of kelp is changing with heat and with stress in the environment. And that led me to the Braybrook Laboratory, where some scientists were working with kelp and looking at their genetic information. For a note, kelp is 180 million years old. So if it was a timeline, if we condense that to a timeline of 1 year, humans would only spend 2 days with kelp. Like kelp is really, really, really old. So we were looking at this heat shock protein in both California and Peru and studying how it's changed over time and if they're having different effects in different locations. This is in the Braybrook Laboratory where one of my coworkers is cutting up the kelp and processing it for its DNA. So this is a process of crushing it, diluting it, stirring it up, condensing it, and investigating what you find, and then making this big reveal and conclusion. And so here we're putting it in the PCR machine after we put it in the wells. And then it's this might look like very complicated data. Is anyone here studying biology? Yeah, awesome. So this is the process of transcription to translation. So you're seeing all these amino acid and these base pairings that go with it. And so we were taking 2 lines of data. We were taking Peru and California for kelp. And we started to color code how they're similar or different. So how these two areas were responding very differently to heat in the ocean or having a very similar effect. Our bodies are made up of, like our DNA is made up of many different amino acid chains. And so it's an extremely complex pattern. It's kind of like a book where you can open different chapters for different parts and different functions. So the heat shock protein is something that responds to heat, it responds to stress, it responds to toxicity in the environment, which can relate back to plastic if you have extra toxicity from the polyethylene. With that, we used software to break up the patterning and make it look like the blade of a kelp. So kelp has this really interesting dynamic because it needs to be in water. And so you get this patterning that you can see in a lot of nature. So if you've ever gone to the beach and you've walked along the shore, you can see the water lapping on the beach and you can see this kind of wave-like pattern, which is the process of water influencing the way that it looks. So taking that data and then turning it into an interactive installation that people can play with the science. So these are two giant buoys. I could fit in them. They're so large. And then in addition to that, I took 300 pounds of sea urchin shells from the Nature Conservancy in Fort Bragg. So sea urchins is another thing that's been happening with the forests, that they've been replaced completely by urchins because urchins eat kelp, but there's nothing to eat the urchins. So you're getting lots of urchins, just monocultures of urchins, no kelp forests. And it's not necessarily urchin's fault. The urchin is endemic to the kelp forest. It's the fact that we've been pushing those dynamics by influencing many things. So burning fossil fuels and allowing the CO2 in the ocean to increase. The temperature is going to increase as a consequence. And then as a result, this was my thesis show for grad school. I can play a clip of the interaction. And then it has a bit of ocean sound in the background. But you go up to the buoy and you reach your hands into it like you're treading water. And you can see it's highlighting the areas of the DNA that are different. So you can compare the difference and the similarity. And then in the second buoy was video from Port Orford, where kelp forests historically had sea otters, but sea otters were hunted to near extinction in the 1800s. And as a result, you lose a predator that was eating the urchins and managing the number of species that could eat kelp. So it's a surplus in grazers and a loss of those primary predators. Oh, I just remembered I have this actually. Okay, so I mentioned earlier disease in the ocean is increasing because the temperature in the ocean is becoming more likable to human blood. So the one species that was really impacted by this, and they just released a report this past month determining what the bacteria was. It was a Vibrio bacteria that they were infected with. This is sunflower sea stars. They grow to be like larger than dinner plates. They're massive and they're really fast. So there's a lot of conceptions about snails being really slow, but these like are on the move. They can get from one point to the next. They can pry open abalone and like large shells. They can eat urchins, like everything. They eat all of it. And so as part of my process, I always try to make things thinking about how to not go out and buy something. So in this case, I usually find the material I know I'm going to work with and then investigate all the processes that can be taken to use that material specifically. And so this was a low density, I wonder if there's a clicker, a little pointer. This was a low density polyethylene. So to insert part of the science process into the art process, there were people on campus at CSU Channel Islands that had a spectroscopy device. And so we were looking at the exact makeup of this. And then that also tells you what chemically is being released into the ocean. And then here, they're being milled. So I took a 3D model of them and started to mill them out to look like sunflower stars. I did the same thing for this other random plank that we found. We think that this was a part of a pontoon for an ROV, but when we scanned that, that was like a low density epoxy. And all this information helps me when I'm programming the machine to make the object, because I know how fast to make the drill bit spin. I know how long it's going to take to make it. I know what kind of difficulties I might run into. And so it's that science of materiality. And that was part of that first installation I did. And then this year, they got moved up to the Sunflower Star Laboratory, which is an aquaculture facility that's working to restore the population of sunflower stars. So we used to have them up and down the coast from Baja to Central California. Now they're completely gone. There's none. We also used to have sea otters. So we lost two very important predators. And so they're trying to grow them from teeny tiny they have this like planktonic phase, so they like turn from algae to snail. It's wild. You have to look it up if you're interested in it. But so they're growing them from sunflower stars that they have at zoos and aquariums up north, and they're hoping to eventually bring them back into the kelp forest, so that species is back there where it belongs. And so they have tanks with 72 different sunflower stars, and that also helps them like study like if they get sick, what it might be. So it's a super important facility. They started up just really recently in the 2020s. And so I wanted to bring this piece there. It's an interactive piece where you can touch on the different sunflower stars and it'll play audio of the kelp forests and what it sounds like for snails to graze on kelp. And that was a collaboration with the national park and Ben Gottesman from Purdue University, who's a soundscape ecologist. Okay, this is kind of a trek backwards and forward at the same time. This was a piece that I did in 2023. So if you think of the first pieces I was showing you where I was weaving these large interpretations of data, I wanted to create a device, a loom, that could weave in the round. Weaving is usually flat and like kind of like a blanket. And so I created this device that it was warp weighted, so all the tension in the structure is created by silk thread and rocks hanging off the edge of them that were found. This was a huge, like, challenging beyond, like, it was really, really complicated. So every single piece was milled, everything was made from scratch. There wasn't a design like this. So I was trying to engineer a few different options for it. But I was also thinking about the sustainability of it. So I had to buy these plywood bases because I didn't find anything in the environment that I would have been able to use without buying. And then I thought, okay, so I kind of gave myself a number. So the carbon footprint of plywood is this number. To try to offset that or to try to balance my practice, I was on the beach one spring, in spring 2023, and there was this massive shipwreck because there was a lot of storms. And so I was walking down the beach with my friend. There was like a sign that said, "Do not go here, do not keep walking." And I kept walking naturally. And I was like, maybe that was like for this area of the beach or, being naive. And me and my friend were walking and we ran into a group that was cutting up a boat that had shipwrecked. It was a really beautiful boat, had really these like stainless steel rails. And I talked to the guy and he was like, "You're not supposed to be here." And I'm like, "I'm so sorry. Can I have some of that steel?" And he was so annoyed I was there. He was like, "Absolutely not. Like, I was like, "It's for an art project, I promise." And that made it worse, actually. I don't, that made it less likable somehow. And so I was walking down the beach and I was bummed. I told my friend, I was like, "That's exactly what I needed to finish this piece because I needed the top structure to stand up. I needed there to be something holding it in place." And so we were walking and we'd left we were in the parking lot and they had a real big rollaway dumpster that they were filling with all the stuff they were sawing up from the boat wreck. And there was a guy there. And I was like, he didn't talk to the other guy yet. So I talked to him and I was like, "I'm building this." I had a different approach this time. I wasn't trespassing in this case. So I was like, "I'm building this art project. I really just need some steel. Is there any way I can take that steel that's already in the trash?" It was already in the dumpster at that point. And I was like, "I want that piece right there." And the guy kind of looked at me like, "Really? Like, you want this?" And I just gave the please, please. And so I was able to get some of these pieces. And when I first got them, they were like rounded. They were not exactly the shape I wanted. And even like in this structure, I don't know if you can see it exactly, but you can see there's like these little joints that I added to it. So the pieces weren't even as long as I wanted them to be, but I had these couplers that I can put on it. Did this take way, way, way longer than buying steel at the store? Yes, it took a lot more time, but I can tell you it was worth it because it doesn't increase a carbon footprint in my practice. And so I valued that and I wanted to move forward with that. Wherever possible, I try to use materials that I find. And that's a close-up. And then that's one of the things that I wove on this. So this is a DNA interpretation of a type of algae where I did the base pairs. There's 4 base pairs, 4 amino acids. And so I switched it to just 2. Okay, transitioning a little bit further here. The project that I'm working on right now. So I did this giant loom. It was really complicated to engineer. I did all this interactive stuff, and I'm kind of moving away from grad school. And I'm spending more time in the ocean and thinking about what it means to be in an ecosystem that you're not really, I can't breathe underwater. I have limitations as a human, and all of that really excites me. And so I was thinking that to design with the ocean and to make a sculpture underwater, you really have to abandon a lot of the rules on land. So there's a reason that astronauts go into tanks when they're training to go up to space. And that's because there's no gravity in the water. So even just something like going down, having lead on your weight belt and descending, it's you have to use your body in a way that you wouldn't normally. And also it's a lot of pressure on your body. So it can be hard on the body. And then I found this quote that summarized that really well. And it says, in diving, the vestibular system intertwines with buoyancy perception as it picks up bodily orientation and works with other somatic senses to keep a diver balanced. And attention to touch as hapticality requires an understanding of how the body acknowledges and negotiates space. So underwater, everything is 4 times closer to you. All the sounds travel a lot further. So a sound that's coming to you, you have like pretty bad perception of where it's coming from because the wavelengths travel really long in the water. And then everything after 30 feet is just blue. So it's like if somebody put a filter on this room and it was blue, you would have a very different perception of the space. And then when you exhale, your whole body starts to sink. When you inhale, your body goes up. And so you're just like, it's like trying to walk for the first time. You don't quite know how to do it because you haven't really negotiated gravity with your body. So you have to have that renegotiation to space when you're underwater. And then you have this tank strapped to your back. And so there's a clock telling you, you're getting really close. You have no air. You have no air. And then you have an extra tube where you can share with somebody. And so it's this whole experience where you're thinking about just the fact that being alive, you have to have certain materials that are non-negotiable. So we have to have air. If we didn't have good air quality, we wouldn't be able to survive in the world. You have to have something that grounds you. You have to have a way of using your body in the space, and that's going to look different for every single person. And so all of these things are very heightened when you're underwater. And I wanted to create something that I could play with underwater that takes into consideration all of those elements. So buoyancy, the physics of water, fluidity, and also uses materials that are found. So this is an irrigation tubing that we found on the islands. We found this like huge cluster of it. Like it was over 100 pounds, the amount of irrigation tubing we had. And then I thought, well, I can't really use the tubing because it's just like this thick tubing. It's like not really flexible. And so then I thought, okay, what else could it be if not tubing? So I started to cut it in half on the bandsaw, and then I started to cut it in quarters, and that took a really, really long time. So yeah, I spend a long, long time on pieces in the sake of sustainability. But sustainability is about the long run, not about the short product that you get. So just try to think about that in your art practice, regardless of, you have an assignment due, like, oh, it's about the assignment, it's about the product. But it's really like try to, in any way in your life, like try to find sustainability. And I'm not just talking about in art, but also like mental practices, physical practices. Sustainability is something that's practices over a long time. If you, go for a long walk one day and you're like really anxious or stressed about tests, it's not going to be relieved in one walk. But if you go on that walk over like 3 weeks, it might do something. So time is steady in sustainability. The other object that we found a lot of are these bait containers. And bait containers are put inside these commercial lobster traps and has like little fish grits in it, and the lobster are attracted to it, and they're all made out of plastic. And so I didn't like it, the form that I was presented, but I started cutting it up and utilizing it for weaving a large sculpture that I wanted to make. So this is, in the middle is one branch of that sculpture. And then this is one of the cross sections of that. So if going back a little bit, this is an elk kelp. This is a really, really deep sea species that I wanted to replicate through my process. And I wanted it to have the same buoyancy. So this float, this round part here in the middle, is filled with carbon monoxide, actually. And I read a couple, like people have told me they've read a couple papers where like you don't want to inhale that because there's enough carbon monoxide there to really like cause some harm because carbon monoxide is completely poisonous to us, but also other sea creatures, so they know not to eat it, which is really interesting. And then all of this is kind of like a tube. And so I needed to create a way to make it have buoyancy. So in diving, they have these surface marker buoys, and I was putting that in these long strips of the tubing so that it will float underwater. So this is still an artwork that's in process. And right now I'm at the phase of creating the blades for the piece. So these are recycled sails from the boating center in Oxnard. And then here are all the bait containers, irrigation tubing, and a buoy. So really it's four different things to make one new thing. And so it just takes looking at the object and thinking about it in many, many different ways. That is my presentation, and that's where I will leave off. Sorry, quickly, we can go back to the first slide in case anyone didn't see it. If you want to learn more about ocean science and are curious to learn about different perspectives in art and science and humanities, join our talk. Yeah, all right. Oh, no. No, they're smaller. So I think we can go back. Yeah, so I wanted to make it 4 times larger than an actual elk kelp. So I took measurements at the beach for an elk kelp that washed ashore. And then I wanted to make it 4 times larger because I'm going to submerge it underwater and then have divers go and write stuff on the blades as a part of a performance. And so this is the actual size of it. And then like this person would be 4 times smaller next to my sculpture. So I think it's like 20 something wide and probably like 30 feet tall. Yeah. Will be. Yes. Yeah. Ooh, that's hard to answer. I have a lot of favorite spots. The Northern Channel Islands are some of the best dive sites in the whole world. And I really am biased towards kelp forests because I think they're really incredible. Monterey, California has just amazing kelp forests. They have these huge fields of anemones that are all really bright colored. It's kind of almost like tropical, but really cold at the same time. The last place I dove was San Clemente Island, which is next to Catalina Island. And that environment is super interesting because you get a lot more warm water coming in from the south. So you get sea turtles and kelp, which just kind of makes my brain numb because it doesn't seem like they should be together, but they are. Yeah, good question. Yes. Yeah, I do. Yeah, that's definitely something I think of, and I always try to have the light source coming, like at least one light source coming from above, and descending down on the sculptures. And it will definitely be like that underwater. And then sometimes I have like a second light lighting it from the side. But yeah, good question. Yes. Ooh, that is a very complicated question. I love this question. This question is one that I think about often, and it's hard to, yeah, in the context right now, I think that a lot of climate and sustainability is being put to the side, especially with admin right now. But I try to listen to podcasts that are optimistic about it because there are people out there that still really want to fight for climate and sustainability, and it's not going to disappear. Like, even though there are a lot of orders in place to not prioritize that and not have an economic system that takes sustainability seriously, it's really important, and a lot of people find it really important. And even those that maybe historically are less inclined to be sustainable in their practice, I'm noticing that even those groups of people, like the lobster fishermen that I work with, are interested in sustainability and do want to work with it. And they're finding that like, there's like a roadblock with how the economy is set up. And so we need more people thinking about market and demand, and keeping products local is really important. Yeah, is my thought on that. Thank you. Yes. Yeah, so yes, exactly. So the lab really wants to reintroduce the sunflower stars, and that was their primary reason for growing them. Um, but there's a lot of state permitting and regulations in the ocean up until the 25 mark, and then it's all federal water. So it's very complicated. I love these questions because they're complicated to answer. But there are things I think about all the time. So it's a very complicated process, and it's also it becomes political because when a species hasn't been somewhere for a very long time, and there are other stakeholders at play that might not want the reintroduction. So I know sea otters is very politically charged, and Alaka Alliance has been doing a really, really good job at connecting people. And Alaka, so Alaka Alliance, Alaka is the word for sea otter. And they're in the Siletz Nation, and they're in I want to say Central Oregon, and they're thinking of reintroducing otters there, and they have a feasibility plan, and they've done a lot of that back end work. Yeah. So it's interesting. Like those we haven't yet gotten to that point where they've been reintroduced, but it's going to be interesting to see the next 10, like I'd say like probably a timeline of like 10 years, which seems long, but sustainability in the mindset of long term. Yeah, yeah, yeah. So much. Yeah, so much. Like even birds, like coastal birds, rely on kelp and kelp rack for nesting and food and everything. And the flies that are like eating on the degraded kelp, like the whole ecosystem gets messed up when one thing is taken out. Which is why we need diversity. We need biodiversity for that reason. And when you don't have biodiversity, you just have these areas of the ocean that are just like monoculture. There's, no economic benefit. So fishermen can't fish in areas that are just complete urchin barrens because the fish don't flock to them. The fish spawn in the kelp forest. So you get massive schools of fish. You get lobster that live there. There's like huge differences. And like, yeah, there's a huge effect on the economy. And so and that's where the sustainability and working with the economy is really interesting. So the sea urchin problem, for example, in Santa Barbara, they have this aquaculture facility called Cultured Abalone, where they're taking sea urchins from these barrens. Sea urchins can live for like 10 years without eating, so they're not economically viable because nobody wants to eat something that has no meat. Although, unless, it's like kind of like eating a jar of Tums instead of something that's like sushi. Because Tums is just calcium carbonate, and so is a sea urchin shell. And so if they're just empty, there's nothing there to gain. They need the kelp to be an actual like product. And so they're taking them from the barrens and trying to like fatten them up with some kelp and then using that as a product. Like one of them is like uni butter, where they're making this like my friend Max Goldman is making this really awesome product with uni and butter as like a cooking ingredient. Yeah, with the barons. So trying to like think of restoration. That's like an application of restoration and economy, where it's like I have this product, but it's going to be using something local, and it's going to be thinking about restoration in the process. Did I answer your question? I feel like it was long. Okay, long-winded answer.